Well, let's talk a little bit about controllers. How many of you have automatic irrigation controllers? Few of you. How many of you are confident in your abilities to program that irrigation controller? Not as many, but okay. All right, good. That's really good. One important thing you should know is who's the manufacturer. Because, oh, how many of you actually still have the manual? Yeah, I see fewer and fewer hands with these questions. These are easy to lose. Maybe you bought your house and the previous owner didn't even leave it for you. Who knows what happened to it? Dog ate it and whatever. The reason it's important to know who the manufacturer is because you can go online. All the manufacturers have this manual online, so you can download it, print it out, and have it readily available. And the manufacturers provide very detailed information. They want you to use their product the way they intended, the way it was designed, so that you have a good impression of their product. If you don't understand it, then you're likely to be frustrated, and of course, what do we always do? We blame the device. It's never our fault, right? It's the device's fault. So the manufacturers want you to understand. And again, you can call your water agency. They will send someone like me out to help you out. Sometimes reading's not good enough. Sometimes a lot of us learn hands-on and by someone demonstrating to us. So take advantage of that resource as well. So you know this. They're either interior or exterior mounted. So it's good to know where your controller is. Sometimes I go to someone's house and they don't even have a clue where the controller is. It's buried behind a bunch of boxes in the garage. So these are really important things to know. You want to make sure, as all new irrigation controllers do, that it has a non-volatile memory. That means if the power goes out, it's not going to wipe out the schedule that you programmed in there. It'll save that program, and then when it has power again, it will continue on. So for your controller, you want to be sure that you have multiple independent programs. Usually it's A, B, C, D. So that allows you to have different hydrozones, different areas that have different water needs, and you can program specifically for those areas. Different run times, different start times. Be sure that you have multiple start times for your programs as well, particularly if you have sprinklers. Because you might determine that you need, let's say, 30 minutes per week for your beautiful green lawn, but you know you have a heavy clay soil, and when those sprinklers come on, after maybe 8 or 10 minutes, the water starts to run off. Well, you can't run it for 30 minutes. You're going to have water running off. But you can break it up into 5 or 10 minute cycles so that it comes on, say, at 5 o'clock for 5 minutes, and it shuts down. It comes on again at 5:30. 5 minutes, it shuts down, and it does this until it's applied the amount of water that's necessary without exceeding the infiltration rate of the soil and allowing water to run off or just go down and be lost to deep percolation where it's not available to the plant roots at all. Water budgeting is very important. So the controller will have a feature like this Hunter Pro C. So no, I'm not a Hunter rep. However, they are very generous. They've been very generous to me in Cabrillo College over the years, and have donated lots of equipment. It is a great manufacturer. They make really good products. It's just what I have a lot of because they've given me a lot of stuff over the years. But Rainbird, Irritrol, there are lots of other good manufacturers, good name brands out there. I just happen to have a lot of Hunter products because they're generous. So on this one, they call it seasonal adjustment. We're going to go through this irrigation scheduling exercise shortly, and you'll understand better what I'm talking about here. But basically, you can create a program for the month of June because we already agreed that the month of June is the highest water need use month. And then you can adjust down from there. You don't have to go and change the program every month because you have the seasonal adjust, which you can adjust it down to 90%, 80%, 65% over time. And it's just as easy as going to that dial and pressing the button down to 50% or whatever it is you determine you need. So you're using 50% of the water that you're using in June, maybe in October, before the rains come. A range shut-off device capability is actually required by law now. So basically, it'll look something like this. Sometimes there might be a bucket, a tipping bucket, right? So when there's a certain volume of water in it, it tips over, basically disrupts the circuit from the controller to the valve and will not allow that valve to come on. This particular type here has these little wafers inside, and they expand when they're wet. Again, it disrupts the circuit, does not allow the controller to activate the valve during the normally programmed time, because it's saying, oh, I'm wet, we don't need any water, it's raining, or it just rained recently. Make sure that it has the non-volatile memory that I referred to earlier. Most of the new high-quality controllers have that. So that's very important, because what used to happen is they had a default setting. So you went out of town, and of course the day you leave, the power goes out. Well, the power comes back on a few hours later. You're out of town for 2 weeks. Oh, but the manufacturer decided that this default setting would be every day for 15 minutes. Well, now you're gone, and every day for 15 minutes, all your stations are running through, and you come back and you see your water bill, and you don't know what's going on. The landscape looks great, but your neighbors were complaining because water is running down the street, and so that doesn't happen anymore. The default settings are gone. The non-volatile memory holds your program, so you don't have to worry about power outages. And of course, again, any of the high-quality controllers are going to have an off, so that you can just turn it off, turn it completely off. Usually by November, you should just turn it off. The rains are either here or they're coming. We hope. And then when you turn it back on, again, it will hold that same program. And manual is another good one, because you're going to be doing your troubleshooting, right? So you'll need to turn it on manually. You'll need to understand how to do that. And I wish we had time to go through some of that stuff, and I wish I had enough controllers, but it's just not possible. So come take my class, and we'll do all of that. Okay, and again, I mentioned the rain sensor a minute ago. There's also soil moisture sensors. This is fairly new in landscaping. Farmers have been using this for years. I use this a lot on farms. Very helpful to have soil moisture sensors, so you can see what's happening, what the plant roots are seeing, where the water is available. Oh, is it getting too dry? So in this case, with landscape irrigation controllers, the sensors are not triggering an irrigation necessarily. They're acting in a similar way as that rain sensor. They're preventing an irrigation from happening. They're saying you adjust the sensor to a certain level, a moisture level. Even though it's not measuring soil moisture content, it's measuring soil moisture tension. Okay, but you adjust it where you want it, and say you program the irrigation to come on Saturday at noon. But the sensors are saying, oh, no, there's plenty of water here, we're good. Okay, it's not going to come on. So that can be a very helpful device. Okay, so I usually take 2 class periods during the semester to go through irrigation system design. And gee, are we over at 12:30? What time are we over?
12:25.
Oh, okay.
I'll give you a 15-minute.
All right, thanks. I don't have time to go through all this. Okay. Take a picture. This is going to be available on the website. You need to understand basic hydraulics. Here's a quick tip. The way to increase pressure is not to reduce the diameter of the pipe. How about that? So many people think that's true. You're going to decrease your pressure, and you're probably going to damage your equipment in the meantime. You need to understand how water flows through pipes, how pressure is lost or gained. And those are usually the grueling classes doing lots of math, and it can be a challenge to walk 30 students through that. But they all appreciate it and walk away with a much better understanding of how to design irrigation systems. You want to obtain your site information as well, fairly obvious. Determine your irrigation requirements. We're going to do that shortly. What's your water supply and your flow rate? How many of you know what the maximum flow rate you have available at your house? Nobody. Okay, good. Oh, okay, one person does. All right. Oh, I don't have any. I'm accustomed to a dry erase board in here. I was going to do something. Is there one? Oh, no, there's another one usually here. So anyway, there's a bucket method. Well, there's two ways you can do it. You can do what I said earlier. Go to your water meter, use a stopwatch, run the water for 1 or 2 minutes, see how long it takes, and then you'll do some math and you get your gallons per minute, right? Or you can do what I call the bucket method. Let me see. I can just do this so that it's visible. It's quick and simple. Get a 5-gallon bucket and use this formula here to determine what the flow rate is. And it's important to know what the available flow rate is because you don't want to design a system that exceeds the amount of water that you have available. Okay, can everybody see this? This is okay, no, of course not. It's a simple cross multiplication problem here. On the right side, we have x over 60 seconds. And on the left side, we have 5 gallons divided by y seconds. So you're going to take your bucket, put it under the hose bib, use a stopwatch, turn the water on, tick, 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 tick. Okay, it's full. Let's say it took 20 seconds. Now cross multiply, 20x equals 300, right? 5 times 60 is 300. So 20x equals 300. How many gallons per minute? Was 300 divided by 20? 15. 15 gallons per minute. Okay, that took you a couple of minutes to do. Now you know what your maximum flow rate is. You don't want to design an irrigation system that exceeds that amount. Oh boy, there's the... Okay, there it all is. We have to move on, folks, because this is not a design class today.